Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem kth element of two arrays. So the problem statement says that given two sorted arrays A and B and an element k, the task is to find the element that would be at the kth position of the combined sorted array. So in the examples we can see that array A and B is given and k is given 5. Now if we merge them and we write them separately, uh, we will get, let's say we write this in a different array after merging them. So we will get 1 2 3 4 and 5 is not there, 6 is there, 7 8 9 and 10. Now we have to return the fifth element from the starting. So 1 2 3 4 fifth. Fifth element is 6 and that we have to output. So the brute force approach which can come into my mind is that we merge them and we create a new array. So, but this will take linear time complexity. All right. So this will take linear time complexity, but we don't want to do this linearly. Why? Because earlier we solved the problem how to find median of the two sorted arrays, and similarly here this problem is just similar to that median problem. I would suggest that you should first solve that how to find median of two sorted arrays, then solve this problem will be very easy because the same code we can copy and paste, just simply changing the value of q. Because see, in the median what was happening, we have again have to merge there, and we can use binary search there, and similarly here also we can solve this problem. Why? Because see, in the median we were dividing the problem such that exactly n by 2 elements are there, and half of the elements are there, let's say, if odd number of elements are there, and for even there are on the left side there are n by 2 plus 1 elements. Similarly, here if we have to find the kth elements, and if we decide the boundary here, so let's say k, we want on the left side 5 elements. So if we create a boundary here, and when we say just give me the left boundary element, and this left boundary element is 6, and this element will be only the fifth element. So this problem is very similar to the median of two sorted arrays. Here, there what we have to do on the left side, we have to place n by 2 or n by 2 plus 1 elements. All right. And here what we have to do, we have to just on place exactly k elements on the left side. Understood? And our answer will be the left boundary element. So this way we can solve this problem using the approach we used in median of two sorted arrays, and we will use the same approach here, and it is highly suggested and advised to solve that problem first. You can watch it on my channel or any other on internet. So now if I explain how we can solve this, so I'm taking the similar example here, the example one only. So I am given an array A that is 2 3 6 7 9, 2 3 6 7 9, and V is 1 4 8 10, 1 4 8 and 10. Now our k was 5, we have to find fifth element. So what if uh, we have to merge them, then we can find the fifth element. But using the same approach as we did earlier, what we can do, if we try to place, if we create a boundary, if we, let's say this is an imaginary boundary, and if we try to place 5 elements here, exactly 5 elements here, that is k elements here, and on the right side exactly n minus k elements here. So let me rewrite this. Exactly n minus k elements there. So here how many elements will be there? So in total there are 1, 2, 3, 4, 5, 9 elements are there. So exactly 9 minus 5, 4 elements are there. And all the elements that are in sorted order. So if we place first 5 elements in the sorted order on the left side and on the right side the rest of the elements correctly, then we can easily find our answer by saying that this element, this left boundary element will be our answer. How? Let's say if we can place 5 elements correctly, that is the starting 5 elements, that is 1, 2, 3, 4 and 6, and here also the rest of the elements are 7, 8, 9 and 10, then 6 is our answer because that's the uh, kth element. So now we will try to place exactly 5 element on the left side. Now how we can place it? So again we will choose any one array. We will choose the smallest array with less size, that is this 1, 4, 8, 10. So let's say my first array, I will consider a smaller array as my first array. You know why? Because uh, we can save our time. We can save our time complexity. I hope you have solved that problem earlier. Median of two sorted arrays. This is just the same pattern question, nothing else. Two lines of code we just have to uh, modify. Everything is then nice. Now, because see, uh, why I'm using smaller array, because when I will tell you later, and I hope you already understood that because our time complexity of log of n1 in n1, this is the size of the array. So we try to choose the array with lesser size so that our time complexity will reduce. And how this time complexity came, uh, I hope you already know, and I will explain it also. So now my array A will be the smaller array 1, 4, 8 and 10, and my bigger array is 2, 3, 6, 7, 9. 2, 3, 6, 7 and 9. And now my task is to place exactly 5 elements on the left side. Exactly 5 elements on the left side. So I have to place exactly 5 elements on the left side. So how I can place 5 elements on the left side? So either I take 0 elements from first array and all the 5 elements from the next array. So if I take 0 elements from the next array, so my first possibility is, first case is, I take 0 elements from the first array. So from A, if I take 0 elements from the first array, so here I'm not taking any element from the first array, that is A, and from the second array I'm taking all the 5 elements 2, 3, 6, 7, 9. And yes, we also have to keep in mind that what if 5 elements are not present in the array B, because let's say if there were only 3 elements in the array B, then we cannot take we cannot uh, we should not go on this case where we are taking 0 elements from A. We should start from a minimum value, that is if there are 3 elements in this array, just imagine there are only 3 elements in this array. So and we have to place 5 elements on the left side, it means that I have to start from 2, that is I have to start from 2, that I have to take I have to take 2 elements from A. I have to take 2 elements from a minimum, then only I can, if I take 2 elements from array A, then I can take three elements from array B. Then I should proceed with going to 3 and then 4, and also at the last also, so that we will decide what's our low and high point. So we will talk it about later, but I just gave an idea. So if I take 0 elements from A and all the 5 elements from array B, this will look like this. And now on the right side, on the right side, rest of the elements are there from the array. Rest of the elements are there, 1, 4, 8 and 10. So, and the next possibility is what if I take just one element from array A. If I take one element from array A, so this will be like I took 2, I took, sorry, 1, I took 1 here, and rest of the elements I took from rest of the 4 elements I took from array B. Okay, 2, 3, 6, 7, 2, 3, 6, 7. This way I placed exactly 5 elements on the left, and on the right side rest of the elements 4, 8 and 10, and here also rest of the elements, that is 9. Now third possibility is that I took 2 elements from array A and 3 elements from array B. So from array I am taking 2 elements, that is 1 and 4, and from the array B I am taking only 3 elements, and rest of the elements are on the right side, and here also 2, 3, 6, 7 and 9. And the next case is when I took 3 elements from array A. So if I took 3 elements from array A, this will be like 1, 4 and 8, and here only 10, and here I am taking just 2 elements from array B, and here 6, 7 and 9. The next possibility is I take 4 elements from array A. So this will be like 1, 4, 8 and 10, and from array B I have to just take 3 elements. I have to just take one element, and on the right side I will be left with I think nothing, and here I will be okay. Here I have to take 2. It should be 2, and here 3, 6, 7, 9. And in the next possibility I am saying that I will take 5 elements from the array, but here we can see that we cannot take 5 elements from array. So here we have to restrict our what do we say, range, that we can just go from minimum of we should not go in this case where uh, our this number of elements taking we are taking from array is exceeding k. So we can decide that our low and our high. So what will be our high? High will be our minimum of k and the size of the first array, so that we are not exceeding k. All right. And now in the low also, in the starting I already explained that low should be what we if there are not much elements in B, so we have to take a minimum number of elements from A in the starting. So that number of elements will be what? That will be what? The uh, total number of elements in the array. See what I'm saying, that let's say in the array B there were only 3 elements. It means that from array A we don't have to start from 0. If k is 5, let's say k is 5, and we have to, on the left side, we have to place 5 elements, and let's say there were only 3 elements. This 7 and 9 I am erasing for now. Let's say there were 3 elements. So we cannot start from 0, because if we start from 0, it means that we are not taking any element from A, and we are taking 5 elements from B. But there here 5 elements do not exist. So at minimum we have to start taking 2 elements from A, and this two where it came from. This came from what? Uh, K minus the size of B, that is n2. So K was 5 and size of n2 was 3. So minimum we have to take 2 elements from A. Alright. So that's why we will start our loop from maximum of K minus n2 and K minus n2 and 0. Alright. So this will save us. So I will just set, have I should write here 7 and 9 also for now. Now our low will be what? Maximum of K minus n2 and r0 was there, because if K minus n2, let's say if n2 was greater than K, then this will be negative and low cannot be negative. So we I have placed 0, I have placed 0 also. So this will be my low and high. And why low and high? Because if you have to check stuff from 0, 1, 2, 3 and 4, why do we go linearly? We can go uh, using binary search. So we can just convert our time complexity from linear to uh, logarithmic. So this will work. So now low was in the starting what? K minus n2. K was 5 and 2 was also 5. So this will be 0. And high was what? K was 5 and n1 was what? 4. So this will be 4. So what did my mid came? My mid came 0 plus 4, 4 by 2, 2. So my mid came 2. So now I will go to this case and check whether this case is correct or not. What is this case? What is 2 here? 2 means that I am taking exactly 2 elements from array A and rest of the 3 elements from the array B. And now I am checking whether this arrangement is correct or not. That because I am placing 5 elements on the left and rest of the 4 elements on the right. So now I have to check whether this arrangement is correct or not. So we already know how do we check. We just check what is L1, what is L2, what is R1 and what is R2. So if L1 is less than equal to R2 and L2 is less than equal to R1, it means that this case is correct. And here also 4 is less than equal to 7, yes, and 6 is less than equal to 8, correct. So this case is correct and we got our answer in our first iteration only. So now we will say that this case is correct. And now what will be our answer? Our answer will be nothing but the left boundary element, and left boundary element is what? The maximum of L1 and L2. So maximum of L1 and L2 is 6 and our answer is 6. So and we can see our output is also 6. So now how did we find L1 and L2? So first of all I will tell you, I know you already know, because you solved the problem median of two sorted arrays. So but I will tell you that why, how we are checking that this case is correct or not. So see, if see on the left side, left elements should be less than equal to the right elements, because the array should be sorted. So if I have this L1 and I have this L2, this R1 and R2, I don't need to check. I have to see. I have to compare the left elements and right elements. So these are on the left side, all elements are sorted, and on the right side, all elements are sorted. So I have to just here compare the maximum value from the left side and minimum value from the right side. So here I have L1 and here I have R1. So why to compare this L1 and R1? Because they both are from the same array. 4 and 8, and 4 and 8 were already in the same array, so they were already sorted, so they were already less than equal to. All right, so I need to just check this L1. I just need to compare this L1 with R2, that if 4 is less than equal to 7, it means that this combination is correct. And again I have to check here also, if L2 is less than equal to R1, then if both are correct, that is if both L1 is less than equal to R2 and L2 less than equal to R1, both are correct, then I will say that my case is correct, that my arrangement is correct, because then I will be sure that all the left elements are less than equal to the right elements. So this way I will get a correct arrangement by placing exactly 5 elements on the left side, and the left boundary element, that is max of L1 comma L2. This will be my answer. And now how we will find L1, L2, R1 and R2. So L1 will be what? L1 will be what? How we will find L1? So R so see, our mid was 2. It means that we have to place we have to take two elements from uh, array 1. It means, where is my array? If mid was 2, let's say mid was 2, it means, and this I will write the uh, what do we say, indexes also, 0 1 2 3 4. So see, if mid was 2, and it means that I have to take two elements from array, that is 1 and 4. So if I want to find L1, L1 was in this case what, 4, that was the second element. So how will I find second element? Array of mid minus 1. So here also my L1 will be what? Array of mid minus 1. And yes, I will also check before just finding mid minus 1. I will also check that mid minus 1 is greater than equal to 0. I mean, that out of boundary case I will check, because let's say how can I explain that? Let's say if mid minus 1 is not existing, so let's say in this case, if I compare L1, L2, they are not existing. So in this case I will set L1 as minus infinity, and in this case this was R2, and in this case I will set R2 as positive infinity. So this will return true. Okay, so this will return true. Now what was L2? Similarly, L2 was also the, if mid was 2, and I mean I have to take two elements from the array A, and then how many elements I have to take from array B? Rest of the elements, that were what? I have taken two elements from here, and I have to take now k minus mid elements from here. So my L2 will be what? K minus mid minus 1. And R1 was what? The third element. R1 was the third element here, that is 8. So that will be just array of mid. This is just array of mid. And R2 was what? R2 is also the k minus midth element. And yes, I will check that these all indexes are in boundary, inside the boundary, and they are not exceeding their boundary range. Otherwise I will put them minus infinity and positive infinity, and they will just return true for that case. And where there were we found elements, we will just check that this L1 should be less than equal to R2, otherwise this case will be wrong. And yes, what do we'll do, what, let's say we are at any mid, this is low and this is high, and we are at any mid, and this, let's say if it is true, then we will return true. Then we will return what we have to return here. We will return the answer, that is my left boundary element, that will be maximum of L1 and L2. What if this mid is wrong? What we will do in that case? So we will decide that whether to move left side or whether to move right side, because we have to eliminate one side. So how we will decide that which side to eliminate and which side to take? So see, if I talk about this case, that is L1 is, in this case what is happening, 10 is greater than 3, but I want L1 should be less than equal to R2, but here we can see L1 is greater than R2. It means that we have, here you can see that this L1 is greater than R2, this 10 is greater than 3. It means that this 10 should be on this side. All right, so it means that we have to take less elements from array A. It means we have to take less elements from array A. So it means that we have to reduce our mid, because mid was what, how many elements we are taking from array. It means that we have to reduce our mid. So see, uh, if L1 is greater than L2, if L1 is coming greater than L2, we will move left side, and on the else, that is uh, on the else case, that is L2 is coming greater than R1, in that case we will move right side. All right, so now if I go and just implement this, so first of all I will just what should I do? Yes, I will declare the sizes. This will be a dot size, and this is what, n2. This is b dot size, and k we already have, and now we have to just decide our low. So what was our low? So we can see that low was maximum of k minus n2, maximum of k minus n2 and 0, and high was minimum of k and n1. And yes, I want my n1. See, what is the time complexity? We are using binary search from low to high, and we are uh, deciding to take how many elements from array A. So the time complexity is coming big O of log of n1, where n1 is the size of the smallest array. So in the starting, I will decide that, let's say, if my n1 is coming greater than n2, it means that uh, my array A has the larger size. So I will say, just call this element. We can swap the arrays also, but I don't want to modify the given input data. That's why I'm just calling it in the reverse order. So I will just call b a n k, simple, and so this will ensure that n1 has the smaller size, all right, of the array. Now I will just simply use the binary search logic. We already know what was our mid, low plus high minus low by 2, and now what we have to do, we have to find L1, L2, R1, R2. So L1 was what? L1 was what? Was array of array A of mid minus 1, but we have to also check that mid minus 1 should be greater than equal to 0. And if it is so, now I will say that this will be array of mid minus 1. Otherwise, I will set this as minus infinity. And similarly, L2 will be what? Array B of k minus mid minus 1. But I have to again make sure that k minus mid minus 1 is coming greater than 0, and if it is so, then this will be k minus mid minus 1, and otherwise this will be minus infinity r1 r2. What was r1 and r2? So this will be array of mid. So but this mid should be less than n1, then only we can say that find array of mid. Otherwise it will go out of bound, and if it is going out of bound, I will say that make it positive infinity. And similarly, R2 is also what, k minus mid, and this k minus mid also should be less than n2. Alright, then only I can just say that go and find b of k minus mid, otherwise make it positive infinity. Now if my case is correct, that is L1 is less than equal to R2 and L2 is less than equal to R1. L1 is less than equal to R2 and R2 is and L1 is less than equal to R2 and L2 is less than equal to R1. Then I will say that when this will happen, then I will say just return my left boundary element, because now I will be ensure that the left boundary element will be my kth element, because we already understood that, and that will be my maximum of L1 and L2. And in the else if case, that is L1 is coming greater than R2, then I will say that move to left. And how we move to left? By reducing high, by moving mid to the left side. And in the else case, we can just move to the right side, and at the end just return dummy value we can return -1. And if I just compile and run it and check whether we have not made any mistakes, so it should submit and compilation processing. And if I just submit this and check whether we are able to pass all the test cases or not, so we can see that we have solved this problem successfully. And now if I talk about the time and space complexity, so we can see that we are using binary search, and our low and high is dependent on how our low and high were dependent from of which array fro, from which array they were dependent. That I am how many elements I am taking from array A, 0, 1, 2, or up to n1. I mean low and high are also there. So either I am taking low number of elements or I am taking high number of elements. So that's why time complexity is big of log of n1, where n1 is the size of the smaller array, and I have made ensure here in the code. And now time space complexity, we can see that we are not taking any space, we are just taking variables. So this was all about this problem. I hope you understood. Till then, keep learning and keep upgrading yourself. Thanks for watching. See you in the next video.